Hi, this is Module 10 and it will be the final video for Module 10. It's covering pages 338 through 342, which brings you right up to the last experiment of the module. And today we're going to be talking about titrations, which might be a new word for you, but in the experiment at the end of the module, there is a titration that you will get to perform. Yay! I used to love titrations when I was studying chemistry. First though, we have to talk about using concentration in stoichiometry. Have you missed that word? Well, we need to review it and do a few stoichiometry problems at the end of this module, okay? So, in using concentration, remember the unit is molarity. It's written with a capital M. I wrote it down here. And molarity actually means moles per liter. How many moles there are in how many liters, usually per 1 liter. Okay, and if you are real familiar with those units, then these next rules will make sense. They are also written in your book. When the number of moles is divided by the volume in liters, your answer will give you the concentration or the molarity, capital M. Okay? When molarity is multiplied by the volume in liters, you will end up with how many moles you have. So remember, in stoichiometry, you are able to look at a balanced equation, and if you know the number of moles of your limiting reactant, you can predict and you can figure out how many moles of your products you're going to end up with. So if you know the concentration of something, then you can figure out the moles. It's loud. Sorry, someone loud was just walking by. It's a very busy household. Okay. So let's try an example. Now this, warning you, may be tricky because we haven't done any stoichiometric problems for a while. So I will have to refer you back to Module 6, where we did most of our stoichiometry problems. We learned how you go from grams to moles of something, and then you can go from moles of the reactant to moles of the product, and then moles to grams again. If that's all kind of fuzzy to you, you're going to have to look back at Module 6 and refresh your memories, okay? We're going to do example 10.6. 10.6 is on page 340. And it says, one way to make sodium sulfate is through the reaction of sulfuric acid, H2SO4, with sodium hydroxide. How many grams of sodium sulfate can be produced if 500 milliliters of 1.6 molar sodium hydroxide is reacted with an excess of sulfuric acid? All right, so we're going to have a lot of steps in this problem. The first step is to figure out the balanced equation. So we are reacting sulfuric acid, which is H2SO4, with sodium hydroxide. Sodium hydroxide is sodium, which I know has a 1+ charge, hydroxide, which has a 1- charge. So you flip-flop those numbers. Since they're both 1, they cancel each other out. And so our formula for sodium hydroxide is NaOH. So we are reacting these two. We want to first break these apart into the ions. So sulfuric acid is going to give off hydrogen ions, and then it's going to be left with the sulfate ion, SO4 2-. Sodium hydroxide is going to have a sodium ion and a hydroxide ion. Okay, when we break these apart into the ions, we can see who's going to donate the hydrogen. That's the acid. The hydrogen is going to be donated over here to the hydroxide to make water. Whoops. And we know that when we have an acid plus a base, we create a salt and a water. The salt we're going to make is Na, which has a 1+ charge, combined with the sulfate, SO4, which has a 2- charge. So we drop the charges, and we flip-flop those numbers, and so that formula is Na2 SO4. So that's the salt that's produced, and water, which I'm going to write as HOH. All right, now that I've figured out my products, I'm going to rewrite the equation. H2SO4, we recombine them into their formulas to write the balanced equation. H2SO4 plus NaOH yields Na2SO4 and HOH, water. Okay, let's start with our hydrogens. We have two hydrogens, lone hydrogens over here on the left. We have one lone hydrogen. Remember, I'm going to save the OH, the hydroxide, for later. So I'm just looking at the first hydrogen out front here. We only have one. So I need to put a big 2 in front because we know that we're going to need 2 of these HOH molecules now. Okay, now that we have 2 H's on the right and 2 H's on the left, now I will look at hydroxide. I now have 2 hydroxides on the right because of my big 2 coefficient out front. 2 hydroxides on the right, so I need 2 on the left and my reactants. So I'm going to put a big 2 coefficient out front of this compound. Now I can look at my sodiums and my sulfates, okay? I have 2 sodiums. I have 2 sodiums in this product. And I have 1 sulfate, SO4, and I have 1 sulfate, SO4 on the product side. So this is the balanced equation. I will circle it so that we can refer back to it later. Okay, so the first step is to find the balanced equation for the reaction that's happening. Next, we need to do the stoichiometry. 1 was balancing the equation. Balance equation. Second step is to do the stoichiometry. Just as a reminder, use the moles of your limiting reactant, the reactant that's going to run out first, to calculate the moles produced for each of the products. So the question is, going back to the example, it says, how many grams of sodium sulfate can be produced if so much sodium hydroxide is reacted with an excess of sulfuric acid? Okay, if there's an excess of sulfuric acid, this is not going to run out first. That means that the sodium hydroxide is going to run out first. So this is our limiting reactant. So we're going to be looking at moles of sodium hydroxide, and from this we are going to calculate how many moles of sodium sulfate can be produced. That's where we're headed. So the question is now, how many moles of sodium hydroxide are in what it told us we started with. We started with 500 milliliters of 1.6 molar NaOH. All right, refer back to these rules that we wrote at the top here. We want to find how many moles. So we want to use this second rule because we want to know how many moles. So it says when molarity is multiplied by volume. So we're going to take the molarity, which is 1.6 molar NaOH, and we're going to multiply it by the volume in liters. So I know that 500 milliliters is equal to 0.5000 liters of sodium hydroxide. And if I multiply that out, I get 0.8 moles of sodium hydroxide. All right, now if you remember from Module 6, at least I believe it's Module 6. Let me look real quick. Oh my, I just turned right to the page I was looking for. This figure right here is very helpful. It's on page 179. It's figure 6.1 in Module 6. And it reminds you that you can go from grams of one chemical, convert it to moles of that chemical, And then you use the stoichiometric coefficients, those big numbers out front of the balanced equation, to convert from moles of that chemical to moles of another chemical, and then convert to grams of that chemical. Okay, so you might have to refer back to there if you're like, what is she doing? I forgot this. All right, next step, we're gonna do 0.8 moles of sodium hydroxide, and we want to cancel out moles of sodium hydroxide because we are interested in knowing how many moles of sodium sulfate we are producing. So we put moles of sodium hydroxide on the bottom so that those units are going to cancel out, and we are moving to moles of sodium sulfate, so that is on the top. Okay? Now looking at our balanced equation, for every 2 moles of sodium hydroxide, so we put a 2 next to moles of sodium hydroxide, we produce 1 mole, so we put a 1 out front here, of sodium sulfate. So that's how I filled in the numbers from those coefficients in the balanced equation. So you're going to do 0.8 divided by 2, which you can figure out in your head. 0.4 moles of sodium sulfate is produced. Unfortunately, we still have to do one more step because the question asks us how many grams. So then we take 0.4 moles of sodium sulfate, and we have to multiply it by the molecular mass. How much does 1 mole of sodium sulfate weigh? 1 mole of sodium sulfate. This is where you have to add up. You have to add up the mass of sodium from your book. 2 sodiums, 23 plus 23, plus 1 sulfate, so plus 32.1, plus 4 oxygens, so plus 16 times 4, and that's how you figure out how much 1 mole of this compound weighs. If you put that all in your calculator, you get 142.1 grams of sodium sulfate are in 1 mole of it. Okay, the moles of sodium sulfate, those units cancel out, so we're going to be left with 57 grams of sodium sulfate is produced. Wow, that was a lot of steps. But that is how you use concentration to know how many moles of the substance you have and then be able to predict how many moles will be produced in the reaction. That's how you use concentration in stoichiometry. All right, let's erase this, and I have one more thing to cover today, titrations, so that you are able to do your titration and experiment 10.2. All right, the book gives you one definition